Hi, my name is Stephen McGee and I'm the author of Toxic Health. I'm here to show you a common error that people make when they're testing their water system with an oscilloscope. Now, this oscilloscope is probably one of the ideal ways of measuring for this problem because it has dual power. It can be powered off an AC mains cable, which is plugged in here, or it can be ran off its internal batteries. And the way I inform people to perform measurements is to always use an oscilloscope that is powered off its internal batteries. And this eliminates the ground connection that occurs through the cable into the household system. I'm going to show you the instrumentation error that occurs on water systems when you use an oscilloscope that is actually connected into the electrical system. And the water system right now is actually currently grounded to the electrical system, and that connection is known as the neutral connection in America, and that's the utility neutral connection, which connects into the ground at the home through ground rods and becomes the ground connection. So we're going to turn on our faucet and we're going to measure the voltage that is on the water in this home. So currently you can see that we have a flat line on our oscilloscope. So I'm going to put the end of the probe into the water and we can see what happens. And there's no change. Now, at this point you may assume that there's no voltage on your water. Now you can see that we're just picking up some little bits of noise coming off the water. And you may be satisfied with this particular reading, but I'm going to show you what actually happens when you unplug the connection from the wall. So we're taking our probe out. I'm going to unplug the wall connection. So the oscilloscope, the only connection it now has to a grounding system is into the garden through this non-electrified ground connection. And we're currently flat-lined because our probe is open-ended. So let's put this in the water and see what happens. So we're now in the water and this is what we get. So that's 60 Hz AC. So it's quite different. And each of the divisions on the oscilloscope is 200 millivolts AC. So we're currently at 6 divisions peak to peak, and that gives us 1.2 volts AC. So I've just taken the probe out. Now let's undo the ground connection over here. So we're now disconnected from the AC electrical system, and we can put our probe back in the water and see what we get. So there we go. So it's gone up a little bit, and the waveform shape has changed somewhat. There's less distortion on this particular waveform. And let's do one last thing. Let's plug it back in and see what kind of reading it gives us. So now back on AC power, and the oscilloscope is now getting its ground through this connection right here. And let's see what we get. So we're currently flat-lined because we're not on the water. Let's put the probe in the water. And there we go. Very similar. And that is because the water is now no longer referenced to the AC electrical system, because the voltage is actually being generated through induction by cables that are running in parallel with the plastic plumbing on this house. So there you have it. It's very important when you're doing AC voltage measurements on the grounding system of homes and on the sine wave of the voltage waveform to actually be using a battery powered oscilloscope to get accurate readings. If you don't do that, you will find that your readings are actually inaccurate and incorrect and may actually mislead you into thinking that there are no problems on the water and grounding system. Hope you enjoyed this presentation, and I wish you the very best of health. Thank you.